Okay. Hello, Assalamu alaikum. Dear student, I just add some examples related to matrix of linear transformation. So let us take some more example related to previous lecture number 30. Find the matrix of linear transformation from R3 to R4 defined by T of x1, x2, x3. This is defined over here with respect to standard basis of R3 and R4. So we have to find the matrix of transformation from R3 to R4. It means we have to calculate the matrix of transformation. The order of matrix of transformation with respect to this linear transformation will be 4 cross 3. So we have to find the matrix of transformation corresponding to this linear transformation. So the standard basis for R3 is 1 0 0 0 1 0 0 0 1, and standard basis for R4 is 1 0 0 0, then 0 1 0 0, then 0 0 1 0, and then 0 0 0 1. So we have to put standard basis of R3 in this linear transformation and return the output as a linear combination of a linear combination of a standard basis of R4. Like if we have put 1 0 0 in this, that is x1 is 1 and x2 is 0 and x3 is 0. So in that case, our output will be 4 tuple, and it can be written as 1 1 0 0 plus 0 1 0 0, then 0 0 0 1 plus 1 0 0 0. In that case, if you can look over here, this element and then this element and this one and this element is fundamentally the standard basis of R4. It means the output this output can be written as a linear combination of standard basis of R4. Similarly, if we can put the standard basis of R3, there is R3 second standard basis of R3, this, which is 0 1 0. In this linear transform we will get 1 1 0, and once again we can return this as a linear combination of standard basis of R4. So similarly we can do for third one. So if we can look over here, the this is first element. It can be written as the matrices of the order 4 cross 3 means a 4 rows and 3 column into 4 rows, 1 2 3 4, and 3 1 2 3 column. So in that case, if you can look over here, this is 1 0 0 0 1. So 1 0, and then there must be I must say there must be 0. So just say one mistake. There must be 0. The student, you correct it over here. There must be 0. So 0 1. The second one is 1 1 0 0. That is 1 1 0 0. And third one is 0 1 1 0. 0 1 1 1. So we have to write the coefficient of this linear combination. This is this one, this one, this one, this one in this first column, second column. So it must be 0. So if you can look over here, like I must correct it. So so the matrix is 1 0 0 0, that is 1 0 0 1. So second one is 1 1 0 0 1 1 0 0, and third one is 0 1 1 0 0 1 1 0. So dear student, this is one of the matrix of transformation corresponding to standard basis of R3 and R4. Let us take one another example. Dear student, if you can look over here, the linear transformation from R3 to R4, that map vector in this domain is into range element. That is 2 tuple is map on 3 tuple under this transformation T. It means this one. Under if you can apply T on 1 1, it will give the output 0 1 2. That is the vector 1 1 map on 0 1 2, and the vector minus 1, it must be comma vector minus 1 and 1 map into 2 1 3. What matrix does T represent with respect to standard basis of R3 and R3? R2 and R3. So the we have to calculate the matrix of transformation. So the order of matrix should be 3 cross 2. In this case, we take one general element, general matrix of 3 cross 2, and we multiply it with the domain element that is of 2 double, that is x1, and we multiply this with the matrix, and we have to find out the a b c d value in order to exactly predict the linear matrix of linear transformation corresponding to this T. So we have some information that under this transformation T, we have just these information are given. Instead, here we have an linear transformation. We have just this transformation. That is this one one two tuple is map on three tuple like in this way. So under T minus 1 and 1 is map on 2, 1, 0. So let us take one element, general element from R square, and matrix is of the form 3 cross 2. We have to calculate because this is a transformation from R3 to R2. So the matrix is of the order 2 cross 2. 2 cross 3. So T of x is A into x. A into x means, since this is a linear transformation, so we have take t of x is equal to a into x, the general form of linear transformation. So in that case, if you can multiply x1 x2 with this matrix, so we'll get this again um, it must be it must have it must be 3 cross 1 column vector. So dear student, if you look over here, this is our x coordinate of linear transformation, this is our y coordinate of linear transformation, this is our z coordinate of linear transformation. But this is not completely predicted. It must, if you calculate a b c c d e f g values, then we can say this is completely predicted. So we have to calculate put t1 t11. It means when x is 1 and x2 is also 1. So we place in place of x1 and x2 we place 1 1. So we get a b c d e f. And t under t11 is map on 0 1 1. This is equivalent to this one by the given condition. So if you look over here, dear student, like so from here, compare x coordinate with x coordinate of right hand side, and the y coordinate of left hand side is compared with y coordinate of right hand side, and z coordinate is compared with the z coordinate of left hand side of this equality. So we get three equations. Similarly, t of minus 1 2 is when minus 1 and 1 is map on 2 1 3. That is two elements, two-dimensional element map on three-dimensional element. In that case, dear student, we are doing the same, that we have put in the position of x1 minus 1, and in the at the position of x2 we put 1. So in that case, minus 1, in if you can put x1 as a minus 1 minus a plus b, so plus c x3, that is again you can see this should not be x3, it must be x1. So minus c plus minus uh, if you can put minus 1, that's minus e plus f, and this is equivalent to this one. So this is equivalent to this, and we have put linear transformation over here. The put x1 in place of minus 1, x1 in place of x1 we place minus 1, and in place of x2 we place x2, and this is actually equivalent to this. And we again once again compare the similar step as we have did for this step. So we get again three equation in term of a b c d e f, which we have to determine. So dear student, if you can look over here, we have to solve this system of equation given in equation 1 and 2. So ultimately we get a is equal to minus 1, b is equal to 1, c is equal to 0, d is equal to 1, e is equal to 1, f is equal to 1. We have to put all these values in our matrix, which is we take it as a general matrix. in order to predict. So with the help of this calculation, we get the completely predict determine the matrix A having six values. So this is matrix of a transformation corresponding to this linear transformation. So let us take another example that find the matrix of a linear transformation T from r to r square defined by T of x is 3x 5x with respect to standard basis of r and so dear students, standard basis of r is e, which is 1, and standard basis of r2 is 1001. So we have to calculate t of 1, that is standard basis of r is 1. So we have to calculate t of 1. This is 3 5, and 3 5 can be written as 30 plus 05. That is, this can be written as a linear combination of a basis of output vector space. The output vector space is R square. So the standard basis of R2 is 1 0 and 0 1. So ultimately the output can be written as after applying the input basis of input, and this we will get 3 5, and this 3 5 can be written as a linear combination of a basis of a output set, that is R square, which is E1 and N2. This is 1001. So ultimately, if you can look over here, 3 5, that is 3 5, the matrix of linear transformation. This can be confirmed from here. The transformation matrix order of matrix will be 3 cross 1. Sorry, 2 cross 1. So here we get the same order of matrix of transformation. So dear student, let us take another example. It's quite interesting examples. So find the linear matrix of linear transformation from r squared to r cubed to r squared defined by this linear transformation with respect to standard basis r3 and r2. So the standard basis of r3 is 1 0 0 0 1 0 0 0 1, and standard basis of r square is 1 0 0 1. So you have to put standard basis of input in your this basically linear transformation, that is 1 0 0. Ultimately you will get 3 5 plus 0 5, and this is I mean to say this is you can say over here uh, let me correct it, it should not be like this. Okay, so you will get 3 5, and these 3 5 can be written as a 3 1 0 plus 5 0, because the output we have to write the output after applying 1 0 after applying transformation t on the standard basis of r3. You will get output this, and this output can be written as a linear combination of the standard basis of output set, which is r square. This standard it can be written as, this element can be written as linear combination of standard basis of r square. So this one 1001. Similarly, if you can put 0 1 1 in this, that is the standard basis of r3 in over here. So ultimately you will get -4 and 3. Then it can be written as a minus 4 comma 0 plus 0 comma 3, and this further can be written as a linear combination of standard basis of r square. Similarly, you can do for third standard basis for r cube, so we'll get ultimately this one. So if you can look over here, the we have to find the coefficient of what you call these linear combination, and put it in column form, that is 3 5, that is 3 5, and this is -4 and 3, -4 and 3, then 9 and -2, then 9 and -2. So you can look over here, the matrix of linear transformation, the order of matrix of linear transformation will be 2 cross 3, which is same as over here. So once again, another example. So we have to find out the matrix of linear transformation from R4 to R. So in that case, dear student, if you can look over here, the order of matrix will be 1 cross 4. That is it has 1 row and 4 column. So defined by this matrix, that is, it take 4 tuple and map on 1 tuple. If you can put 4 tuple, you will get only one value. with respect to standard basis for R4 and R3. So the standard basis of R4 is 1000, 0100, 0010, and then 0001, and the standard basis of R is 1. So so you have to put the standard basis of R4 in this, and ultimately you will get the one values, because it's a one dimensional vector space, and this is four-dimensional vector space. So if you can look over here, if I can put 1 0 0, so I'll get 2, and 2 can be written as 2 into 1. Then standard basis of second standard basis of R4 is 0 1 0 0, so I'll get 3, that is 3 into 1. Then 0 0 1 0, this is minus 7, this is minus 10, 7 into 1. Then fourth basis of R4 is 0 0 0 1, this is 1 1 into 1. So in that case, if you can take the coefficient 1, and this coefficient is again 1, and this coefficient of this one is minus 7, the coefficient of 1 is again 1. So in that case, the as I told you, the matrix of linear transformation in this case is 4 cross 1. It means for one row and 4 column. So dear students, these are some of the examples of our previous lecture number 13. So we can take another example. This is same as we have solved in a previous example. This is same as you can do it by yourself. So let me do another example, that how you can find out the what you call it as a so dear student, this let me take another example. So sorry, this is not complete. I will give you its completion. So you have just to find do practice this example in your home, and hopefully this will really help you out. Inshallah, in next lecture, I will just give you another basically exercise lecture, that in which I will discuss some other types of questions related to matrix of linear transformation, and hopefully I will solve some more example for you people. Till then, Allah Hafiz, and please stay at home. May Allah bless you all.